Welcome to Amber Skies. My name's Blades, and here we are, 3D modelling, as it were. Let's get that started up. So, currently, not a lot of information. We might have to do something about that. What have we got here? No, don't like that style. Try that style. No, nothing going on there. Oh well, so be it. Right, yeah. This is Windows, isn't it? Yeah, well, we can't do half the things we want to do in Windows because it doesn't like it. Stupid. But true. So what I'm going to do is just make a quick block here for notes. There's going to be lots of them. We're about to import all the notes for making of a 3D model. First thing we're going to need is some kind of, information. So, Microsoft Edge, oh dearie me. Let's have a wiki for .obj, please. That's the one. Okay, file format, please. Here we are. Lovely, lovely, lovely. Lots and lots and lots of lovely information. Materials as well, please. We're going to need a lot. See also. References. No, I think I'll do up to about there. Copy. And paste. So, we now have information on how a .obj file is made up, and there's a lot of it. So what we're going to do is we need to create a structure of all of this data. Yeah, in other words, we're going to have to read it all. Oh no. 3D model. Where can we put this? We can put it anywhere we like. What do we have and don't we have? Okay, so we've got main and we've got that, whatever that is. So I've changed my view so that when I add things, it adds real things and not fictional things. So add new folder. We're going to have a source directory, aren't we? Yeah. For source code. Could call it source code, actually. I'm also going to need a development directory in this one because we need to test. So we can add new folder and we'll just call that development. Doesn't look right. I'm sure I've missed an E out. OPE meant? Nah, it can't be that, can it? Development. I don't care. So I've got a source and a development directory. Under development is where we're going to go next, and under development we are going to add a new item. It's going to be a header file, and the header file is going to be OBJ Structure. So OBJ and then structure.h, please. Lovely. Blah, 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 blah. What? You can't add it. Okay, fine. We'll try that again. OBJ Structure .h, please. Add. D colon repos 3D development. OBJ Structure already exists in this. Okay. Cancel. What the hell's it talking about then? Refresh. Don't know. It's being an idiot. Pragma wants. Thank you. Oh dear. It's going to be one of those days today, isn't it? I haven't used Visual Studio or Windows in a while, so bear with me. I don't know all of its real cock-ups, although I've come across enough bugs so far to make me want to go back to Linux straight away. But hey-ho, isn't that great? Okay. What are we going to do? We're going to have a look at our main file. File format. Lines beginning with a new character hash are comments. Oh, wait a minute now. This is a comment. An OBJ file may contain vertex data. Okay, let's do that one then first. So cut. Paste. Okay. Well, let's just put our do breathe in. Toggle. No. Okay, edit. Okay, where is everything on this machine? Format document, blah, 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 blah. Oh, right, it's that symbol there then. There we are. Fantastic, it's a symbol up here. Yay, we're getting there now. Yay. Okay, so what is our response to this? Our response will be do nothing. So that's our response. So we're not going to have anything for that. There we go. Lines beginning with a hash character are comments. And then it gives an example. Do nothing for a comment. Okay, that's a good start. We're programming now. We've made a decision. That, by the way, is programming. It may be in English, but it's programming. As soon as you make a decision about what that is, and you give it an answer, that's programming. So there you go. Your first steps to becoming a master programmer without any language. Yeah, it's true though. Right, what's the next one? Well, this is the one with the bracketed. Yeah, that's going to be fun. May contain vertex data, freeform curve surface attributes, elements, freeform, blah 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 blah. Let's just take the first one, shall we? Which is that one. Cut. And we're going to have to develop this one. Paste. Take the block. Wobble it off. Thank you. So we need a reply to this one now. Right, there's two replies because there's two options. Actually, that is separate. How long is this line? Okay, tools, options. Accounts, auto recover, documents, extensions. Find and replace, fonts and colours, keyboard navigation, quick, yeah, blah, 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 oh my god. Text editor. Yeah, control. Where's word wrap? It's a text editor. Why doesn't it have word wrap? It probably does, but I haven't a clue. Ah. Thank you. Now I can read it all. Obvious, really, isn't it? Surface, body statements, connectivity between freeform, render attributes, information. There. Most common elements are geometric vertices, texture coordinates, vertex normals, and polygon faces. Yay! So, what do we do if we get a vertex? Well, we have to store it somehow. And there are two types. So there is an X, Y, Z, comma, W, and yeah. So we're going to need structure. I'm going to use struct. Yes, no. First of all, let's give this a namespace, because I'm about to write something without it being guarded by anything. So I'll give it a namespace. What namespace shall we use? Let's use 3D model. As a namespace. Okay, that's better, thank you. So, struct. What structure shall we have? It's going to be a vertex. So struct vertex. Yeah, that'll do. I wish I'd do it properly. I didn't have to redo everything that it does, but hey ho. Now, a vertex is, well, structs are public, which is why I'm guarded it with a namespace very quickly, because you're going to have this as public data. Now, what data do we need? We need an X, Y, Z, and W, each of which are floats. So, float X equals 0.0. Now, am I going to put this here or there? Okay, no, we're just going to do that. Okay, float X, Y, Z, and W. Yes, it's 4, but it could be 3. That's why there's that square bracket on it. So it could be 3 or 4. So we need to know if it's 4. So we're going to need a bool. And we're going to call it isQuad. Quad means 4-ish. Well, it does mean 4. And yeah, that'll do. And do we need anything else? W is optional and defaults to 1.0. Or we may as well just use quads. Yeah. If it's got a default value, then heck, why not? So that's just made it a lot easier. Because now what we have is a cat behind me jumping around on boxes. Empty boxes from a computer, which I've just received. That's just made it a lot easier. So really all we need then is a vertex made up from a float. And it's going to be X, isn't it? Oh, God. Yes, I know what I've just done. That should be M underscore X. M underscore Y. M underscore Z. And M underscore W. Thank you. X, comma. Float Y. Coordinate, or whatever you want to call it. Float Z, comma, and float W, and that has a default of 1.0f. There we go. Now I can have a colon, and we are going to make mx equal to x my. Yeah, there's nothing really difficult going on here. All we're doing now is assigning the values to y, m underscore z. Careful, Muppet, you'll fall. This is a big crash in the background, don't worry. I'll be laughing. My cat is called a Muppet for a reason. I'll let you work it out. And that is W. What is W? W is something called a homogeneous point, a fourth dimension. A point in the fourth dimension which holds the 3 dimensions, and we're using 0.1.0f to hold 3 dimensions together. So it becomes a singularity of space and time. Makes everything else relative to it, and that means we can move everything relative to each other. There you go, that was your physics and star-struck casting nonsense for today. Hey, that's W. Look up homogeneous coordinate systems on internet, or go to Cairn University, or whatever it's called. And they do have a very good section on it there. Yeah, it's needed. Without it equaling 1, everything will just disappear. Trust me. It's how things work. If you imagine a drawing of two-dimensional drawing on paper, then Z would be your homogeneous coordinate of 1, which would equal the paper that it is drawn upon. That's the easiest way I can explain it. But we've now got our vertex. Nice. So, what's next? Yep, this is how you program. You do it bit by bit. Okay, what we got next then? Go back to main. Next is this one. So we'll just take that to there. Copy. How do you make a data structure? Well, glad you asked. You do it by looking at the wiki. Oh God, what is it on this thing? Is it Shift plus Alt? We'll try that. Yeah, that seems to be working, sort of. Yeah, that did. Good. Okay. Right. Right. Okay, I understand now. Looking good. So, this will be a struct. So struct. Oh, with my caps lock on. I can't see if my caps lock's on or not. Doesn't tell me anywhere, does it? No. Great. S. Yeah. Okay. Struct. No light on the keyboard. Oh dear. And what we're going to call this one, texture coordinate. That's going to be a long name. But that's the name of it, so it's texture coordinate. There we go. Why has it put it down there? God, Visual Studio, will you get with it? What do we need for this one? Listed texture coordinates in U, V, W. These will vary between 0 and 1. V and W are optional and default to 0. Okay. I'm liking this. It's making my life easy because all you do is exactly what it says. So it's float M underscore U, comma M underscore V. Why do they use U, V and W? Because if you used X, Y and Z, it would suddenly get very confusing whether it was a vertex or a texture coordinate. So to differentiate between it, we just use different letters of the alphabet. Stupido. But it's true. M underscore U. V, sorry, W is again. Again, W will be a homogeneous coordinate, but this time it's set to 0 and we'll probably never use it. But it's there, and you've got to be aware of it. Because if you're not, and they put it in, a program puts it into a .obj file, because remember, this is a specification for a .obj file. If that W is in there, then we need to know about it. We need to account for it. Even if we don't use it, doesn't matter. We have to account for every possibility, otherwise this ain't going to work, is it? So, texture coordinate. And why is I'm getting nothing up? Have I got my struct wrong? No. That should still come up. Interesting. I don't know. Well, not yet I don't anyway. It's not coming up with any errors, so I must be doing something right. So it's float. Float. New keyboard, sorry. Well, I'm getting used to it. V and W default to 0, so float V equals 0.0 F, comma, and float W equals 0.0 F, colon, and assign M underscore U equals U, M underscore V equals V. It's not complicated stuff, I know, but it's the best way to program. The best way to program is just to take the information that you're given, and then, in this case, it's a data. We're talking about data, so what I'm doing is I'm making data structures, because that's the best way of splitting it down so we can code it. Otherwise, it's how we access the data. This defines how we access all data. So put the W in, and W. There we go. And I have missed out something. I've missed out my curly braces. That means do nothing else. That means there's no default thing that you have to do, like multiply one of these by the other or whatever. There we go. We've got our texture coordinate. So you can see how this goes now. I mean, I could go off camera now and just go through the whole of that file doing these. But it's obvious. Really what I'm doing is nothing special. That's now done, isn't it? So we can get rid of those. Thank you. List of vertex normals. Normals might not be unit vectors. Okay, so you can't depend on these being unit vectors, and that is important because if you need unit vectors, it means you have to process them. What is a unit vector? It's when all of these three, when calculated as a vector, equals 1. So it will be that squared plus that squared plus that squared, all square rooted, equals 1. There you go. It's Pythagoras theorem. Yeah, I think that's where it comes from. There we go. I've done some maths on you. You can shout at me in the comments below for doing maths. My apologies. I did some physics before, so I guess it all balances out, doesn't it? Yeah. Okay. Block you off. You're not code. So, struct. What's this one called? Vertex normals. So I can't call it vertex. I've now got to call it vertex normals. Okay. That's what we'll call it then. I've got hair on my microphone. It's really bothering me. I don't know. These things were sent to trials. Oh, it's now worked out how I want to do things. That's very kind of it. So this is an X, Y, Z. Yeah, okay, this is a nice easy one. Float. M underscore X. M underscore Y. M underscore Z. Why aren't these different? Why is this X, Y, Z and texture coordinates aren't? That's because it's a vertex, or it's a type of vertex. So vertexes use the X, Y, Z coordinate system. This doesn't have a W because it actually belongs to a vertex. And a vertex is only shown in 3D as the X, Y, Z part. The W is just its location 4D. So it already knows all of that. So this is actually attached to the vertex. So we don't need a W. Isn't that lucky? Somebody's already worked all this out before us, which is where this data format comes from. So, I mean, it's nothing. It is rocket science, but it's not. Because this is what took us to the moon. To the moon. This is how you get moon at orbits, normal. And it's still not picking up on this. No idea why. Is it because I'm not saving it out each time? Could be. Okay. So it's going to be float. No defaults. X, Y, and float Z. Colon. M underscore X equals X. M underscore Y equals Y. And M underscore Z equals Z. And then we just need our curly bracket thingy-majiggies, and that does it all. Magic. Absolute magic. Looking good already. So I've already got vertex, textures, and normals. What else can we have? Space vertices. Freeform geometry statement, see below. Okay, a vertex can be specified in a line starting with the letter V. That is followed by X, Y, Z, W coordinates. Okay. W is optional, and the default is 1. Some applications support vertex colors by putting RGB values after XYZ. The color values range from 0 to 1. Alright, parameters. So we could use this as RGB. Okay. No, that's vertex, sorry. It said parameter space vertices, parameter space vertices. Freeform geometry statement can be specified in lines starting with string VP. Ah, this is better. You're right. Defined points in parameter space of a curve or surface. U is only required for curve points. Okay. U and V for surface points, and so these are surfaces, and control points of non-rational trimming curves. U, V, W, weight. Okay. For control points of rational trimming curves. So this here belongs to the vertex. Which goes there. Yep, funny. Let's tab it over. Okay, a vertex is in line, starting with a yeah. Yeah. That now makes sense. Okay, so that's the edit for that. Texture coordinates wasn't an edit. Okay. Okay, VP. Let's put this one in. Yeah, I'm having to redo the wiki a little bit for my notes. And you should have notes on everything. And I mean everything. If you don't, then you will never remember everything, because I can't. So, trust me, it would be very hard. So this is parameter space that we're going to be doing. I've got face elements. That's under F. So this is that trimming. This is curves and stuff. There's a blooming good reason for it, because they're useful for curving things, obviously. So VP, pop you in here. And we'll just pop you there. Okay, it's looking good. So parameter spaces are VPs. So parameter space vertices. So it's a vertex parameter. Okay, I can do that. I've never seen one, but I'll do it. Struct vertex parameter. Lovely. And what's this one? Float UVW. Okay, float MU MV MW. And that will now be. I know what I haven't done. I've put these as structs, haven't I? And I've put them all with lowercase. and they should all be with uppercase. Trying to following the naming conventions, my bad. Sorry. It's the same as a class, so everything that's a class starts with a capital. And that includes these. These are not variables, these are public classes, or structs, as we call them, or structures. I don't know why they named it structures. Why don't they just name it a P class or something? Public class. Very weird. Vertex. But this is C++ for you. It's a bit weird in places. Let's have a look. We now want floats, don't we? Float U. Float V, which you see below. It doesn't give defaults for them. It just says optional. So 0.0f. And I've done it again. I've gone flowy. So as optional, I will have to... I'm going to take the Y key off the keyboard. I really am. It's because I'm using the wrong hand. I'm trying not to use my left hand. When I type more with my right than I do with my left. For reasons. W. And yeah, the Y key is... T key is just a bit of a stretch at times. For some reason, I don't know why. Shouldn't be. It's a new keyboard. I'll work it out. U is U. M underscore V is V. Why I'm putting these equal signs in C++, what happens if when you call the constructor to construct your vertex parameter, it will only expect one value. And those two are then optional. But to complete the construction, it will need values for these. So we put the values in here so that we can complete the construction whenever one is needed to be constructed. And there may be a lot of them constructed. And they may have U's and V's and W's, or U's and W's, I don't know. But they can be constructed in many ways. It's just to allow the construction to follow the pattern of the .obj file that we will be reading. There we go, and of course we need our brackety brackets. That's it. What's next? What's next is probably the biggie. Yeah. So this is next. Okay, cut. I bet there's going to be some notes on this. Paste us up. Let's give it a few of them. Now a face is 1, 2, 3, or it's 3, 1, 4, 2, 5, 3, or it's 6, 1, or, oh, forget it. It's a face, so if there is a triangle, or a quad that we're going to be using in this case, which is 4 points, yeah, it's, well, it could be 3 or 4. We are going to need a bool, aren't we? I'll think about it, because that can be 3 or 4 W. We're adding it, but no, because W as a quad will be a vertex position, where W as a non-quad will be non-existent. Okay. We're going to need a vertex triangle and a vertex quad. No, we don't. Okay. Understand now. I know that it does two different things, so it's annoying that, you know, it's one of those things. Face elements, edit. Let's utilize it. Okay, read you in a second. Paste them in first of all. Okay, what do we got? Faces are defined using lists of vertex, texture, normal indices. Polygons such as quadrilaterals can be defined by using more than 3. You know, yeah, you use 4 instead of 3, that's all. OBJ files support free form geometry, which uses curves. Surfaces. Why is that there? Such as NURBS surfaces. Wonder why that comes there and not under there. Because that's what I thought that was. Maybe. Maybe not. Hey ho. Right, so what we are looking at here is a very strange structure. And if I'm right, it's all integers. Because it will tell us a position in the file for each of the vertex, texture, and normal indices. So that's vertex, texture, and normal indices. And they will go in a number like 1, 2, 3. And then it could be 1 double slash, 2 double slash, 3 double slash, with the numbers going in between. So it depends on how many slashes we've got. Right, need to think about that one. No response at the moment for that one. Yeah, it's to do. Then it's colon straight after. Then I have to put in blades. I'll use blades, yeah. No Fraser. There we go. To do. With all variations. That's slightly more complicated, so I'm going to leave that out of this video, and I will show you that next video, because I need to work on that one. It's not something I can do straight off the top of my head, because my head will cave in. Okay, vertex indices, edit. Okay, vertex indices, edit. Alright, this is part of the face thingy. Yeah, there's a lot more here. Line elements, that's the next one. That's all the F's. Cut. It's all to do with the F's. So, there. Yeah, there's a lot of it. There we go. So that's all the information I've got to read through and do. So I've got to be able to do each of these variations here. So there's 1, 2, 3, 4 variations. There accidentally got an extra thing there, didn't I? Paste. So this is the last one that we have to support. That's what it's called. It's a feature support. We are going to support every single feature of the .obj file. See below, I think I better had. Record, starting with the letter L, specifying the order of vertices which build a line. It's an integer. I think. Just thinking. Yeah, it will be. Integers in a .obj file start at 1, not 0. So that's going to cause problems as well. Just to make it a bit more awkward. Thought I'd let you know now. Request specifies the order of vertices. Yeah, we can do that then. That's just going to be struct. We'll call it line elements. Yeah, that'll do. And that's just going to be int m underscore element. Yeah. Vector 1, 2, 3, 4, 5, 6. Yeah, blah 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 blah. So there are a lot of them, or could be a lot of them, just in a row like that going across. I'll think about that, but for now we'll just have storage like that, I think. Yep. I'll come back to that one. I'll put some more thought into these afterwards. That's a better idea. So we need an int element. Is that right? Yep. And that's just going to be m underscore element equals element. I'm only doing it as a singular at this point because I don't know how many elements are going to be. So I don't think we can do it as a multiple read-in. Right, so we've still got more. Okay, other geometry formats. OBJ file support higher order surface using several different kinds of interpolation, such as Taylor B-splines. Although support for these features in third-party file readers is far from universal, OBJ files also do not support mesh hierarchies or any kind of animation or deformation, such as vertex skinning or mesh morphing. Reference materials. Okay, so this is just information. There we go. And they're into mtlib. Okay, so cut there. And that finishes there. Okay. That's that one done. Did you think it was hard? No. It's not hard, it's just doing the information, getting it all together. Now, MTL. is part of the OBJ structure, but it is actually a separate file. It's a material file which comes with an OBJ file, usually created alongside. If there's nothing in there, there's nothing in there, but you know, it's a file that does get generated with nothing or something, either a colour or a texture types and things like that. So we're going to need that, and that, there we go. So mtl external file.mtl file name. In other words, it's a separate file. This tag specifies a material name for the element following it. The material, oh, we do have to do this one, don't we? Name matches a named material definition in an external MTL file. Use MTL material name. Okay, so we need now these up to here. I'm going to take both of those at once because there's two things happening there. And I'm going to leave a thingy going across to make sure I know that we're into a different area. That's a marker just for me. Might name it, yeah. Actually, yeah, we should name it, shouldn't we? Yeah. MTL lib isn't a struct. No. Not that I can see anyway. Really. Let's just size that down a bit. There we go. But it will hold information. It's a bit like this one here. Yeah. Okay. Trying to remember how this looks in a .obj file. There is a reply to this. We have to do a reply to it. It's a must because it's going to come in. We're going to have to store it, aren't we? I'm going to stay with struct because it will then create a convention of how we're looking at this rather than just having a variable stuck here for no reason whatsoever. And I'm just going to call it mtl lib, aren't I? Material. Specifies a material name. I'll just call it material then. It's very important to do this. Material name. Thank you, Muppet. And this is going to be a string. It's going to be a file string. So we actually have to do an include. Include. It's not giving me any IntelliSense whatsoever. What's wrong with this thing? Oh, God. I don't like it. I think that's right. I don't know. I'm not liking this. I'm going to have to look at the IntelliSense off camera as well. How annoying can you get? So it's going to be an std : string. I'm glad I know what I'm doing, because otherwise this would be useless. What's wrong with you, Microsoft? What's wrong with your IntelliSense? Have I not downloaded it or something? I bet I haven't. So it's going to be m_. material name, semicolon, and it's going to be material name std string material name. Keep all the conventions the same, and then it becomes semi-meaningless to you. But what you're actually doing is you're creating a language. That is what this is doing. It is creating a language within which we can program. And that's how C++ works. You basically write your own language. Underscore material name. And that's the good thing. That is why I use C++, because you don't learn C++. What you do is you learn the language that you create with C++ whilst you're creating it. Real weird material name. That's why so many people have a lot of problems with it. It's mainly because they look at it as a language and it isn't. It's a structure of how to do things, C++. It's a way of doing things. I think that's a better way of saying it. In other words, it gives you this structure in which you can do things. Now, this tag specifies a material name for the element following it. The material name matches a named material definition in the external.material file. So we will have struct, and it will be use material, and it's going to be a name, so I'm going to use standard string again. Underscore name matches a name, yeah, and that matches something inside there. Yeah, I think I can work with that. It's not hard. Hopefully not. So use material. This is all information that this OBJ file can give us. It's not necessarily what we're going to get. So, I mean, we're going to use what we get, and if we don't have it, we're going to ignore it most likely, or do something else. Make our choices of how to draw this on the screen using whatever information we've got. I think that's basically what we're programming, is a way, one, to read this from the file, and two, how to get the information that OpenGL requires to draw it onto the screen, or store it on the graphics card at least, to be drawn on the screen. Yeah, I mean, it's not really difficult to do this part. It's just a labour of love. There we go. That's our next one. Many more? That's an important one as well, because we haven't actually done that before. If you go back to Amber SL, I did a very simplified version of this in which we just chucked everything into vectors and then pumped the vectors through to the the graphics card. And it works perfectly well. It's very fast, it's very easy, and it covers the minimum. The vertexes. I don't even know if we put the normals in there. We didn't really look at a lot in that project. We just looked at the basics, but this time we're doing a lot. Okay, this now gets confusing. So O, object name, G, group name. Named objects and polygon groups are specified via the following tags. So there's two of them. Okay, so we'll need two. We'll split that in two, shall we? Yeah. Cut, copy, now need it in here anymore. This has shortened everything down in here a lot, I think. How are we looking now? We're looking quite good. Not too much more to go through, is there? Yeah, OBJ files can get very complicated. Don't have to, but they can do. Now, I'm not really... yeah, I mean, what we're doing is basically storing strings again. Object name, group name. Yeah, they are strings. I remember what they are now. So we'll have them all. There's going to be tons of these. Absolutely tons of them. Objects. So it's an object. Name. I can't use the word object because we're using object-orientated programming, and object is part of Qt as well, so I can't use that. I'll have to put name. Yeah, I can deal with that, I think. And again, it's an std string. Standard library for std, and string is the function that I want. So standard library string. Just call it name again. Just do what it was in the previous one. Yep, so it's up. This is a bit of overkill, really. But I'm doing it on purpose because I want to overkill it. When it comes round to speeding the system up or something, these can be looked at, probably these can be replaced probably just by variables. Variable like std string object name as a variable instead of a struct. The reason I'm putting it as a struct is because I'm going to be doing a standardized way of storage using vectors, and every single structure that we have here will be able to just be placed straight into vectors without any complications whatsoever, and we'll be able to store as many as we are given. And that's the beauty of this, is that we are our file reader just becomes oversimplified. It just becomes one big if statement. If the first letter is such and such, then dump it into whichever, vector we want it to be dumped into, whichever one of these. Use material, object name, vector, whatever. And it simplifies everything out. Object name, yeah. Makes the programming quite happy. I haven't got a clue how much time I've used up so far, because I'm not on a dual system anymore. Sorry. 1 hour 32, I thought so. I've got a time sense that knocks off my brain that does that. Don't know why. So this is the last one that we're doing. These last two. So there's object name, which is std string name underscore name is name. It's just them two in it. Yeah, that's it. And then that's struct. What's the next one? Group name. It's taking a lot of the choices out of things. That's how good programming is achieved. A bad programming is when you make stuff up. Like dumping things out in an OBJ file just to make it work for AmSL. Yeah, slightly made up system. This time I'm doing it properly. I'm going from the bottom up with all the file detailed with the notes, the proper notes that are given from the wiki, and everything. It's better done this way. You'll see why as we get further into it, because it's going to get confusing if we don't do it this way. Name. Changing that variable name, don't need to. So this is now group. For obvious, an obvious thing would be to like join that, and that all into one structure. Yeah, I mean that's an option for later. But for now, don't do anything like that when you're starting up a system. Remember, we haven't got a system overview. We haven't got any kind of idea of what this system is going to look like, which is why I'm putting this under development and not into source, because the source will contain the whole system. Whilst we've got it in development, we keep it in development until it's ready to go into source. So that's standard string. You'll see that we have to do like a development session, a headbanging session, where we actually decide on how we're going to put everything together. That will happen. I mean, there's no two ways about that. Typing and talking at the same time. I'm going to have to learn how to do that, aren't I? I keep stopping typing. I can't talk and type. Ah! There we go. That's them two done. And we have to stop here because we're over the hour. So we haven't finished. Whilst we're offline, I'm going to just go back and have a look at this biggie and see if I can work out what the structure is or going to be, or the structure's multiple. I think because it's C++, we might be using a single structure that is overloaded, or we could do something completely different. Because it's just -1 off all of these numbers, isn't it? Right, okay. We'll see. We'll see, we'll see, we'll see. Yeah, I'll work it out when I get there. So, in the meantime, what I'd like you to do is have fun reading through that wiki article, and I would advise reading through it at least 3 times, then coming back to watch this video again and just follow along with what I've done. You'd probably be able to finish it by then, but I'm not sure how I'm going to do it at this point. So I'll see you in the next episode when we continue getting our data structures sorted out. I called it object structures. Data structure? I don't know. We'll see. Take care, peeps, and believe me, just have fun. Just have fun.